Well, hello there, and welcome to my really bad 15-minute tutorial on all of Python programming. Before I start, I want to point out a couple things. One, this is not meant to be used as a legitimate tool for learning programming. If you really want to learn programming, like for real, there are other sources out there that can teach this better and more eloquently and in greater detail than I ever can. And I'm going to teach this under the assumption that you do not know anything about programming. Okay, now the first thing is, if you want to actually download Python, you can get it from python.org. You can get whatever version you want. I'm using 2.4. You can get, it doesn't really matter that much. On the left here is idle, which is the IDE in which you can enter your lines in one line at a time and have it give you results right away. And on the right is where I've actually defined an entire program, which is basically my lecture notes, haha. And this is going to help me teach this better in 15 minutes. Okay, so the first thing we're going to learn is variable assignment. So variables are your basic building blocks of programming. So on the left, when you define a program like x equals 1. So on the left is the actual name of your variable, and on the right of your equal sign is the value that your variable will equal to. So the variable name x is now equal to 1, and say y equals 2. So x is 1, y equals 2. And if you want to ever print out your results to the page, just use the print statement. Print x will give you x. Print y will give you y. And you can define variables using operators like z equals to x plus y. So z is now equal to 3 because x is 1, y is 2, x plus y is 3, and z is equal to 3. And you can add, subtract, multiply, divide. And here's your modulus operator, so 10 mod 6. The modulus is basically a parentheses sign, and it gives you the remainder of any division. So 10 remainder of 6 is 4 because 10 divided by 6 is 1, remainder 4. So you can also let's say x is 5. X plus equals to 1. That's basically adding 1 to the number of x. So x is now 6. You can say x minus equals to 1. It does the same thing. Okay, next thing, ints and floats. You have to understand a little bit of difference between ints, which are integer numbers like x equals 1, and floats like y equals 1.0. An integer is just a whole number, and a float is just a decimal number. And when you have to be a little bit careful when dividing integers, because dividing integers will give you an integer answer. And if you say 10 divided by 4.0, it'll give you 2.5 instead of just 2. Okay, so now we're going to go on to strings. Strings are basically strings of characters. So say x equals 2, this is a string, blah. And x is now equal to this value of this is a string. So if you print x, it'll tell you that. Most languages have a way of saying if something is true or false. So here's true, and there's false. And here are a set of operators for defining conditionals. So 1 is equal to 1. Now this is a double equal sign, which is different to a single equal sign. A single equal sign is for variable assignment. A double equal sign is for saying, is left equal to right? Is 1 equal to 1? Yes, it is. So that's true. Is 1 equal to 2? No, it is not. So it returns false. So you can say, is equal to is not equal to. That's what that is. Is less than, is greater than, is less than or equal to, is greater than or equal to. And that's just some of the ways you can say if something is true or false. Now what if you combine true and false with and or? Say true and true. For and, both left and right have to be true. And since they are true, it returns true. But if you say true and false, since they both have to be true and this one is false, it returns false. But if you say or, true or true, only one of them really needs to be true, but since they're both true, it returns true anyway. True or true is true. True or false, only one of them needs to be true. This one is true, so it returns true. But if you say false or false, aha, it returns false because neither of these are true, even though it just really requires one of them to be. Put not in front of it, not true is false, and not false is true. So, those are all your conditional stuff, and you can use them in if statements. An if statement is basically something that says, if the following is true, do the following. So if, say x is 5, if x is greater than 3, print x is greater than 3. And it printed it because x is 5 and 5 is greater than 3. So it does the following. But if you take that exact same code, turn that greater than to a less than, is 5 less than 3? No. So it does nothing. Absolutely nothing. And you can combine if statements with elif and else statements. Elif has to come after an if statement. It's basically saying if this is false, try the following. If that's false, then try the following again. If you get to an else statement after an if, a set of if and elif statements, else basically says just do it. If you even get that far, do it. So if y equals 10, and I'm just going to copy this over very quickly. And what does it do? It says y is 10. Why does it do that? Because it says is y equal to 3? No. Is y less than 0? No. Is y equal to 10? Yes. And then it says y is 10. If this turned out to be false as well, it would have done that. Y is a mystery. Ooh. And that's just an extra one. You can try that out yourself because I'm pressed for time. While loops. While loops are basically loops that say, while this is true, do the following. A loop is a segment of code that can repeat over and over and over again based on a certain condition. So what a while loop is basically saying, while the following is true, do the following. It's basically an if statement that repeats itself until it returns false. So while x is greater than 0, print x and subtract 1. So x is 4. Is 4 greater than 0? Yes. So you print it and subtract 1. You keep doing this until you hit 0. So is 0 greater than 0? No, you don't print x. So you stop at 1. Or after 1. I'm not going to run this code because if you say while true, it'll go on forever until you either say break in the next level or the code crashes or you manually stop it. You don't want to do that. Just know that while true will go on forever, usually. List. Now we can go on to list, which is exactly what it sounds like, a list of values. So x equals 1, 2, 3, and 4. So if you put a list in brackets, x is now defined as a list of values 1, 2, 3, and 4. You can put whatever types of values you want. You can say 1 as an int, 1 as a floating number, the string 1. You can put any types of values you can in a list, and you can mix them all together, which is not always true in other languages. So, if you say y is y is this list of strings, and let's say you want to just call this one, just the first one. Well, then you have to index it, y at the index of 0. Now, this sort of trips people up a little bit. In Python, the lists are indexed at 0. That means the first value is index 0, and you just increase by 1 after that. People make a lot of mistakes thinking that the first index is at 1, but it's actually at 0. Just little thing you have to remember. Okay. Python has this really useful thing called range. It basically returns values from 0 up until, but not including the number that you give it. So it's a range of 10, gives you the numbers 0 to 9. It's 10 values, but it's 0 to 9. And the range function is actually very useful for loops. A for loop is a different kind of loop. It's basically saying for each value in this list. So for x in range 5, print x. So we're basically saying x is equal to, hold on, Renage. So we're basically saying x is equal to 0, print x. X is equal to 1, print x. X is equal to 2, then 3, then 4, print x. So it's basically for this variable equal to each item in this list. Do the following. And this is basically the exact same thing as doing that because this is range 5. So these two do basically the same thing. This one is saying for z in range 10, if z mod 4 is equal to 0, print z. So range 10 looks like that. So it's basically saying for each item in this list, if it's divisible by 4, print it. So only 0, 4, and 8 get printed because they're the only ones that return that as true. Okay, next thing, defining functions. And we have a bit of time left. Good. Okay. So functions are very useful because you can define them and they don't actually run until you call on them. So define function name. So this is your basic header for defining a function, the word def, and then, which means define. Then your variable, your function name, and then your parameters. These are the name of your parameters. You don't even need to have parameters, but I have parameters there. Return x times y. So this is the variable, this is the function name, and you can call on it, give it 3 and 4, it'll return 12. It's basically saying the parameters x and y are 3 and 4, and you return x times y, which is 3 times 4, which is 12. So you can define variables that way if you want. So z is equal to function name 2 and 5. So z is, guess what, 10. Because this evaluates to 10, and that's what goes into z. So z is 10. So here we have this function. I'm just going to copy it over and put it there. So it's only got one parameter this time, just x. Just put 5 in there, and it'll return the string x is positive. Because you gave it 5, and is 5 greater than 0, then yes, return x is positive. If you say negative 5, it'll say x is negative. Because it'll say, is x greater than 0? No. Then try this. Is x less than 0? Yes. Then return x is negative. But if you say positive or negative of 0, it'll say x is 0. Because it'll say, is x greater than 0? No. Is x less than 0? No. So just do this, because that's what the else statement does. Return x is 0. Now I'm under the assumption that if a number is not greater than 0 or less than 0, then it has to be 0. That's just what I'm assuming, which should be correct. So here in this final piece of code combines a little bit of everything that I've taught you so far. I'm going to give you a little time to pause the video and try to figure out what this does. It's a little bit tricky, but it's very interesting to see how all of this comes together. So what do you think this will do? That's interesting, isn't it? So basically, you're defining your one parameter number. So for x in range num, so whatever you put in here goes into here. So starting at x equals to 0, so for each number in that range, you define an empty value. You define an empty string of y, and you add a single star for each number in x. That's a bit confusing. Basically, y looks like that. And then you redefine it when x is 1. It looks like that, then that, then that, then that, then that, then that, then that. And I'm sorry, I wasn't explaining that very well, but basically it makes sense, sort of. Alright, so here's some extra topics. Dictionaries. Dictionaries are useful, but I didn't have time to teach them. Class making and object-oriented programming. Python is not an object-oriented language, but it does have class and object capabilities, so that's useful. Recursion is recursion. You have to know it if you're going to do programming. Functional programming, just look it up. Lambda functions. Not many people use them, but it's interesting. Debugging is just useful in general, just knowing how to debug. Python's very good at helping you do that. Here at the end, I just want to give a couple of extra tips to people who are already programmers who are learning Python. One, it's white space sensitive, so tabs and such do matter. It's case sensitive, as it should be. You don't need to declare your variables, like you don't need to say int x equals 5, you can just say x equals 5. And there are no curly braces in Python. And I'm out of time, so thank you and goodbye.